Okay guys, last portion of this chapter, electron configurations. Of course we have rules when it comes to electron configuration. The first one's called the Aufbau principle, and that just means filling up in German. It means we fill the lowest energy level first. So n equals 1 has to be completely filled before we can go to n equals 2. If you look over here in this area, if we have n equal to 1, I can put 2 electrons into one line anywhere it appears. So I could put 2 here, I could put 2 here. Oh. I could put 2 up here, but I have to put my first 2 electrons here, then my next 2 would go here, and then I'm going to put electrons in here. So the Aufbau principle just means you fill up the lowest energy level first. And you'll notice there's something funky going on here. We'll talk about that in a minute. Pauli exclusion principle says that no 2 electrons can have all same quantum numbers the same. And that means if I have 2 electrons in the 1s orbital, like I'm showing here, they have to have different spins. And I'm denoting the spin by an up arrow or a down arrow for plus 1/2 and minus 1/2 respectively. And so if I need to put 2 electrons into helium, helium has 2 electrons. I have to put it into the 1s. I can put up to 2 in that orbital. So the first one goes with an up arrow and the second one has to go with a down arrow. And we use 1/2 arrows to denote 1 electron. And so we have obeyed both the Aufbau principle and the Pauli exclusion principle in this second diagram right here. And the last one is Hund's rule. And Hund's rule says that you leave electrons unpaired as long as possible. So when we get into a p orbital where I have 3 blocks or 3 lines, they're all 3 the same energy, and therefore when I put in the first electron, it would go in the first orbital or the first line, and the second one would go in the second block, and the third one would go in the third block, and then lastly the fourth one would go in the other direction. So we have these 3 rules that we're going to have to apply, and we will practice those in class. So how do we know what electrons or how we fill them? Because it doesn't go directly just 1s, 2s, 2p, 3s, 3p, 3d. We have some little variations. And so in your book there's this diagram here, and it works very well, but to me it's a little confusing when I have to draw things in diagonals as they've done here. We would fill 1s, then 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, and that I find slightly confusing. This is what I've devised, and yes, this is my own device. I start down here on the bottom of 7 rows with 1s, then the second row up, the second energy level, I would have 2s, 2p. Third energy level, I'm going to go directly above the last one, and it always s goes right above p, or you go offset by 1. So after that it's 3s, 3p, 3d. Then after d3 would come s, and s is going to have not only 4s, 4p, 4d, and then 4f. Then 5s, 5p, 5d, 5f. We only need 2 f rows, so I'm not going to have to include anything more after this. And then I would do 6s, 6p, 6d, and lastly 7s, 7p. Now, how do I fill? Well, I go up these red arrows, and then I drop down to the bottom of the next column. So 1s, then 2s, then 2p, 3s, then 3p, 4s, and interestingly enough, 3d comes before 4p, but after 4s. So d kind of drops in between the 4s and p for 3d. And then 5s, 5p, or after 4p is 5s, then 4d, 5p, 6x, etc. You see the pattern? And we will put in as many electrons as necessary. We have to remember that s holds 2 electrons. P, since in this previous slide it has 3 lines, it can hold up to 6. D has 5 lines, so it can hold up to 2 times 5 would be, you got it, 10. And then F has 7 lines, so it could have up to 14. So the periodic table, interestingly enough, is kind of laid out by these S and P blocks. If you notice here, I've kind of got a funny looking periodic table. It doesn't have any of the elements in there, but it has the S block marked and the P block marked, the D block and the F block. And you see very clearly here where each of those electrons fill, and we see here the 4s fills, and then the 3d fills, and then the 4p, and then we go to the next row, it would be 5s, 4d, 5p, 6x, 5p, 6 or 5d, 6p, 7s, and these two rows actually fit up right in here, but we haven't included them. If we did, the periodic table would just get too wide. So we see where all the blocks are on the periodic table. Here's the vocabulary that you need to know for this chapter. I've written it out here, but I will not do that for each chapter. I'll just say make sure you know all the vocabulary. So you need to know the vocabulary. You need to be able to do all the problems that I have separate videos for. We're going to do those electron configurations. We're going to do a lot of those, and we'll be doing those in class tomorrow. So make sure that you have this understanding, and you might want to replay this video and look at it again. But I will take questions, of course, at the beginning of class tomorrow. Okay, thank you. See you tomorrow. Bye. Oh, wait, more vocabulary. Sorry. Okay, the end.